Now let's start our discussion on acid. The acid word is come from the Latin acidus. The acidus meaning sour in taste. So all acids are sour in taste. We see the examples, daily life example like lemon. Lemon is an acid and sour in taste. Now see from where we get these acids. The main source of acid is organic source and other is inorganic source. Organic source means plants and animals like lemon, like apple, like oranges, milk products, all are organic source of acid. And on the other side, sulfuric acid, hydrochloric acid, nitric acid, all are inorganic source of acids. Usually, inorganic acids are corrosive in nature and organic acids are non-corrosive in nature. Now let us understand what is the meaning of corrosive in nature and non-corrosive in nature. If you see that if you put a few drops of acid on the hand, if the acid burns our skin and changes its color, that acid is corrosive in nature, and if the acid not able to do this corrosive action, means not burn to our skin, that acid is called non-corrosive in nature. So from this we can say that we can't taste all acid because some acids are corrosive in nature and harmful for our skin. Now see how these indicators tell whether the solution is acid or not. These indicators changes its color when mixed with acid. Now see what is the color changes to the indicators. Take the example of litmus. Litmus is usually purple in color. On mixing with acid, the litmus color changes to red. On the other side, turmeric is yellowish in color. On react with acid, it remains to its yellow color. On the other side, synthetic indicators, we have phenolphthalein. Phenolphthalein is colorless in nature and on mixing with acid, it remains colorless. And the methyl orange, orange in color, on mixing with acid, it becomes pinkish in color. Further in the laboratory, a litmus solution is prepared. These are of two solutions, usually blue color litmus and red color litmus. If we add few drops of acid in both the solutions, the blue color litmus changes into red and red color litmus remain red in color. These also called the universal indicators. When acid is react or add to these substances, the characteristic smell of these substances increases. Here are the summarized points of acids. You may note down these points. In these points, the first and second point is very important. First point is all the acids are sour in taste. This is the first main physical property. And second main physical property is when acid on addition to blue litmus, it changes its color to red. Going further to acid, one thing is common in the acid is that it gives H positive ion in the aqueous solution. Now what is the meaning of this? When acid is added to the water, it dissociates into cation and anion. Cations are positively charged, usually H positive ions. Now let's see this thing with example. Let's take HCl. When react with water, it gives H positive ion and Cl negative ion. Actually HCl is dissociated into H positive ion and Cl negative ion. H positive ions are reactive in nature, most reactive and most unstable. So it further react with water molecule, gives hydronium ion, that is H3O positive ions. So we can also say that acid are the substances which give hydronium ion in the aqueous solution. Now, depending upon the ionization of H positive ions, acid can be classified into strong acids and weak acid. Now, what is the meaning of this? Strong acids give H positive ions, or we can say that completely dissociate into H positive ions in the aqueous solution. On the other side, weak acids are partially dissociate into H positive ion in the aqueous solution. Now, what is the meaning of this? Take with the example here a strong acid H2SO4. H2SO4 is having two hydrogen atoms. When these H2SO4 added to water, it gives 2 H positive ion in the aqueous solution. But on the other side, in the weak acid, take the example of acetic acid, that is CH3COOH. In this example, there are 4 molecules of hydrogen, but on addition to water, it gives only 1 H positive ion in the aqueous solution. So out of 4, they give only 1 H positive ion. So this is a weak acid, or we can say that partially dissociate into H positive ions. Now, depending upon the H positive ion in the aqueous solution, that is number of H positive ions, we define a new term that is called basicity of acid. If a compound or acid give 1 H positive ion in the solution, that is called monobasic. Example is HCl. If the acid give 2 H positive ion in the aqueous solution, that name is called dibasic. The example is called sulfuric acid, that is H2SO4. And if the compound or acid give 3 H positive ion in the aqueous solution, that is called tribasic. And in this example, there is H3PO4, that is phosphoric acid. Now, coming to the last physical property of acid, that is electrical conductivity. We know that pure water is bad conductor of electricity. If we add few drops of acid in the water, it dissociates into H positive and Cl negative ions. These are free ions, move freely in the water. So this helps to conduct the electricity. That is why acids are conductive in nature. Here are the summarized point all we have discussed yet. You may note these points.